LeetCode problem number 621, task scheduler. So this problem is a bit complicated. What it does is it gives us a characters array called tasks, which represents the task a CPU needs to do, right? So each different letter would represent a different task. The task can be done in any order, and this is the important part where each task is done in 1 unit of time. So for each unit of time, the CPU could either do a task or just idle, which means not doing anything, right? Not doing any tasks. Okay, here we also have a non-negative integer n, and this represents the cooldown period between the two same tasks. And that basically what this cooldown period means is that before, when you execute A, for example here, there needs to be 2 turns where you cannot execute A again, right? When you cannot do A again. So A, since n is 2 here, so it'll be skip, skip, and then A again, skip, skip, and A. It doesn't matter what it does in between, it just cannot be A. Right? Same for B, so B, skip, skip, B, skip, skip, right? So if n were to be 3, for example here, then it will look something like A, B, and then we have idle into another A, and then we have another cycle, right? So A, and then if n is 3, so we have skip, 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 right? We have to skip 3 times before we can execute another A. And in between those skips, you can obviously do something else. Okay, so that's what the cooldown period means. Okay, and of course we have to return the least number unit of time, which means we have to find the most efficient way to schedule all of our tasks that the CPU will take to finish all the given tasks, right? Okay, so knowing that, here I have some examples, right? So my approach to this problem is, if you could see, let me just remove this instead. Is that if you could see this example here, right? This is the easier example to visualize. So this can be grouped into 3 cycles, right? So since n is equals to 2, that means we have to skip 2 times. So here what we can do is A, B, and C in one cycle. I'll group them up like this. And then for next cycle, we will use A and B again, but this time including D, right? And for the last cycle, obviously we'll use A and B. Okay, something like this. So if you notice here, the A, A, B, and then a random character cycle, here it happens twice, right? And this twice basically means that the highest number of frequency, which is 3, minus 1, which is 2, right? Okay. So to prove this, if I were to have another one, another A, for example, then here, then it'll be just A, right? A, B, and then of course we have to idle here. So here I'll put a idle, right? Maybe idle. Okay. So you can see here it's the same thing, right? But now the AB is the highest cycle ones, right? The AB something, AB something, AB something, right? In this case would be 4 A's, which is 4 minus 1, which we get 3, right? So knowing this, we can do the uh, cycle length times the highest minus 1. Okay, so this will only give us this part, right? This formula will only give us this part. So we also need to account for the number of occurrence of how many times this highest had occurred, which in this case it's only once because there's only one 4 A's, right? If there were 4 B's as well, then this would be 2 lah, right? This would be 2. What I mean by that is this would be 1, right? This would be 2 if there were 4 B's instead, right? Okay. So cycle length is basically n, right? But we need to plus 1 as well, because the n in this case is 2, right? And 2 is basically the skip time, which is BC in this case. But we need to plus 1 because we are also executing A itself. So that's where the plus 1 comes from. Okay, then we times the highest occurrence, which is 4 minus 1, which is 3. That's why we get 3 loops over here. This is 3 complete loops, right? That's what I meant by loops, by cycles. This is not a complete cycle because it is a one task itself. So we have 3. So highest minus 1, and then plus the extra 1 here. So if you do this, then it will be 3. You will get 3 plus 2. 6 plus 1 is 7. Right? We get 7, which is 3, 4, 3, 4, 5, 6, 7, 8, 9, 2, 3, 4, 5, 6, 7, 8. Wait, did I count wrongly? Okay, so the highest in this case is 4, right? 4 minus 1 is 3. 3 times 3, we get 9. Okay, I count wrongly just now. So 10. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, just to be sure, let me count it again. So remember the formula is n plus 1, which is the cycle. Then the number of cycles equals to the highest minus 1. And then of course we will have the extras, right? In this case would be 1. So n plus 1, this is 2, highest. In this case, the highest, the number of cycles would be 4 minus 1. 4 minus 1 plus the extra. Basically what this is looking for is how many times has the 4 occurred, right? Has 4 characters occurred in the task. For example, in this one, we only have 1 occurrence of 4. And if you remove this 3, then we will have 2 occurrence of 3, right? 2 occurrence of 3. Okay, since this is 4, okay, so this will simplify to 3, 3. 3 times 3 is 9, plus 1, 10. So you can see here the cycle, the amount of time needed to execute all the tasks will be 10, including 1 idle. Okay, that's enough about the formula. Let's talk about the code. Let me just keep it there. Right. I'll keep these here. Okay, so this will be the highest occurrence, and this will be the number of highest occurrence. Okay, a bit long my verbal names, but here's what it is. Alright, so first thing first, I initialize a vector of 26 size, which represents each character in the English alphabet. So here I also have the highest. So what this highest is basically the highest occurrence, right? I initialize it to 1, and then for each tasks in the tasks, right? For each task in tasks, I would increment the number of tasks in the vector by doing so, right? But basically t minus a, get the ASCII difference, and after that you increment it inside the vector, and then I update the highest if it needs to be updated, So basically after this for loop ends, when this for loop ends, the highest for this case, right, for this case, or let me just use back the old one, right. Okay, for this case, the highest will be 4. The highest will be, let's keep it 3. Yeah, the highest will be 3. And then here, I'm getting the number of highest occurrence, right? That's why I'm iterating through the vector one more time just to get the number of highest occurrence. So for this case, the extras would be 1, or more like this, will be 2, right? Because there are 2 occurrence of 3 characters. Okay, then we put it into our formula. Okay, this is if n is equals to 0, right? If n is equals to 0, then we can basically execute all the tasks concurrently, or not concurrently, but one after each other, because there is no cooldown, right? So basically I'm putting the size of the tasks here just in case that the number we counted is lower than the actual size of the task, which is possible if n is equals to 0, right? So again, the number of cycles, so n plus 1, we know n is 2, and then times the highest is 3, 3 minus 1, plus the highest count, in this case will be 2. So if we simplify this, 6, we get 8, right? So for this example, we will get 8. So if we do some manual scheduling, you can see that it is indeed 8. Okay, so in between two same characters, we have the cooldown period, right? So A, cooldown, cooldown, A, cooldown, cooldown, okay, etc., etc. So if you see here, 1, 2, 3, 4, 5, 6, 7, 8, right? That's 8 unit of time needed to execute this task, basically. Okay, all right. This works as well if there are 4 A's, for example. Then what we need to do is this will be idle and A, right? So in this case, cycle length still be n plus 1. The cycle length 2 plus 1. Okay, since now highest is 4, right? The highest occurrence is 4, and the number of highest occurrence is 1, right? There's only one occurrence of 4 characters. 4 minus 1 plus the extras, which is 1. So we simplify this, which I've showed just now. If this will give us 10, right? So you see here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, including the idle. Okay, hopefully my explanation is sufficient. That's all I have to share.